In this video, you will learn how to create various types of glass for buildings and how to avoid common transparency-related issues in-game. If you're on version 2021 or above, for GTA materials to work, set to max legacy and restart 3ds Max. As a prerequisite to this guide, you need to make sure that the model you are using in-game has the alpha transparency flag. For single player, it is flag 4 located in the object's item definition .ide file. For MTA, it can be enabled in engine replace model, and there is code example in our wiki. First, I want to talk about game limitations. Unfortunately, the game engine, renderware, has some issues with transparencies. The first issue is that if the glass object boundings are too big in scale, then the glass might not render objects, players, or vehicles behind it from certain camera angles. This issue also depends on distance to or from the glass. For that reason, if you need accurate transparency rendering, you may need to split the glass into smaller objects, such as ones with boundings no bigger than 5 meters large. The precise scale in question requires more research. The game also does this with object ID 1649, also known as WG Last Smash. This object is small in scale, which means it needs to be placed several times if your building has several windows, but in turn it prevents the alpha sorting issue that occurs with larger glass objects. The second issue is that the game will only render down to 40% opacity by default. If you would like to render down to 1% opacity, your object needs flag 64, which disables writing to Z-buffer. The first and second issue has some overlap. If the glass has flag 64 and is very large, then some objects and vehicles may cull the glass pixels whenever they're seen through the glass. In this case, splitting into a smaller object will also work. The third issue is that an opaque model generally should not use transparency flag, meaning as a rule of thumb, you should split your glass object into a separate DFF model. There are cases where it's fine to keep the glass and building in the same DFF. With these three issues out of the way, I want to touch on the two types of alpha sorting. Type 1 is where the glass is part of the same DFF as the building. With this type, we need to make sure the glass is drawn last, and that is achieved by setting the glass material ID to last in the model. For example, if our model has 20 material IDs, as a rule of thumb, we need to set the glass as ID 20. If we set it to ID 1, then it cannot see any other material, because it only sees materials that are lower ID than itself. Type 2 is where the glass is a separate DFF of its own. With this type, we don't need to worry about material IDs, but we do need to ensure that it's of low enough scale so that it doesn't hide players, vehicles, or other objects behind the glass, as explained in Issue 1. Now that we have the transparency logic and limitations out of the way, we can move on to the main portion of this guide. I will first show the fundamentals of creating different types of glass, and then implement those methods in models found around the game. Glass 1 is made transparent with solid vertex alpha. Because vertex alpha objects doesn't support light flag, you may not want to use this method of creating glass. Glass 2 is made transparent with solid material alpha. This is among the most common ways of creating glass. Glass 3 is made transparent with solid 2x2 texture. This texture can be made transparent in an image editing application, and can be great if you intend on changing the color in-game with a simple texture shader. Glass 4 is a custom DXT, one compressed opaque glass texture, which is then made transparent with vertex alpha or material alpha. You would usually want to use material alpha for that. Glass 5 is a custom DXT, 3 compressed transcluent glass texture, which is also made transparent in an image editing application. The file size of DXT3 compression is greater than that of DXT1, and so method 4 is best if you care about file sizes. For this trailer, we can keep the glass in the same DFF as the trailer model itself. However, in the wooden house method later in this guide, you will learn how to create a modular glass, which can help resolve glass rendering issues if they do occur. Some of the window models are planar to the walls, which is not ideal. Measure the depth of one of the window frames and extrude the same amount for the planar window frames. Extract the window texture and add some transparencies to it. We need to create a new mesh material ID, because if we add the texture to ID 1, then the glass won't see any polygons behind itself. Export the files. For this house, due to the scale of it, we need to separate the glass into a modular glass piece, which we can then place several times. We could also just use the original game glass, which is Object ID 1649, and then scale it uniquely for each window frame. However, for this video I will be using the house's own window texture to keep it authentic. Start off selecting the windows by material ID and perform a 10 centimeter extrusion. Delete the windows. Create a box at each window frame. To keep this video short, I will only create a few boxes. Create the glass texture. Create the custom glass planes. Create 20 or so duplicates of both types. Start placing the glass in their window frames. This takes some manual effort. You can get the XYZ scale values by going into non-uniform scale mode in 3ds Max. Export to IPL and convert to Lua mapping. As we only need a static prelight for the glass, we can just give it something like a gray color with 100 brightness. Export the rest of the files. To keep this video short, I will not show how to modify the building collision. The building needs colliders in the window frames, as the custom glass will be collisionless. When adding the glass models to MTA, you will need to enable alpha transparency flag in your code. To access all XYZ scale axes in the Lua script, you will need to do some scripting in MTA. Manually transferring the XYZ scale values into your MTA code can take some time, and you will have to make sure you're adding the scale to the correct map objects by referencing their XYZ position coordinates. Position a box that roughly covers the top window rows. Use the Array tool to make this a bit faster. Use the Boolean tool to cut the boxes into the mesh. Set to cookie mode. I know I want my window frame to be 10 centimeters, and so I'll create a box that is 10 centimeters at the corner of the window frame. Border, select the cutouts, and extrude with Shift. Snap to the box to make the extrusion 10 centimeters. For the glass, cap the borders, go into Edge Selection and convert to Poly Selection with Shift-click. Detach to copy and detach individual dual window planes as copies. This way we have two glass planes in one DFF. Object 001 is the actual DFF, whereas the others are only needed for exporting the glass object coordinates to the game. Create a copy of the building's first texture, Frings2_256, and crop out just the window portion. Set the opacity to your desired amount. As we only need a static pre-light for the glass, we can just give it something like a gray color with 100 brightness. Export to IPL. Export the rest of the files. To keep this video short, I will not show how to modify the building collision. When adding the model to MTA, you will need to enable alpha transparency flag in your code.